Welcome back to the podcast, where we dive deep into the world of technology and software development. Today, we're exploring some fundamental concepts in web services and APIs that are crucial for developers and tech enthusiasts alike. We'll break down Wsdl, SOAP, Restful APIs, and message brokers, discussing their roles, advantages, and challenges. So grab your headphones and let's get started. Let's kick things off with Wsdl, or Web Services Description Language. Wsdl is a powerful tool that allows developers to generate code, enabling clients to access remote services as if they were local. You can think of it as a bridge that translates local method calls into XML messages that can be sent over the network. This is particularly beneficial for statically typed programming languages, where the structure of data types is defined at compile time. However, in dynamically typed languages, the advantages of Wsdl aren't as clear-cut. Now moving on to SOAP, which stands for Simple Object Access Protocol. SOAP introduces a bit more complexity. It relies heavily on tools and code generation, making it challenging to construct manually. This complexity can be a hurdle for developers using programming languages that aren't supported by SOAP vendors. Even though SOAP is standardized, interoperability issues often arise between different vendors' implementations. As a result, its popularity has declined among smaller companies, although it still holds a strong presence in large enterprises. So what's the alternative? Enter RESTful APIs. REST, or Representational State Transfer, takes a simpler approach. It typically involves less code generation and relies on tools like OpenAPI, also known as Swagger, to describe APIs and generate documentation. This simplicity is one reason why REST has become the predominant style for public APIs today. Let's take a step back and look at remote procedure calls, or RPCs. RPCs have been around since the 1970s and aim to make remote service requests look like local function calls. While this abstraction can seem convenient, it's fundamentally flawed. Local function calls are predictable. They either succeed or fail based on parameters you control. But network requests can fail due to issues like network outages or server unavailability, which are beyond your control. When it comes to response handling, a local function call will either return a result or throw an exception. With network requests, you face additional challenges, like timeouts, leaving you unsure if your request was received. Then, there's the issue of idempotence. If you retry a failed network request, you risk executing the operation multiple times if the request went through, but the response didn't. This isn't a concern with local function calls. Latency is another factor to consider. Local calls generally execute in a consistent time frame, while network requests can vary widely depending on network conditions. Plus, when making network requests, you have to encode parameters into a format suitable for transmission, which can complicate things, especially with complex objects. Different programming languages also have different data types, so RPC frameworks must handle these discrepancies, which can lead to messy solutions. Given these challenges, it's clear that trying to make remote services look like local objects can be misleading. This is where REST shines. It acknowledges that it's a network protocol and doesn't try to hide that fact. Despite the challenges, RPCs are not going away. Frameworks like gRPC, Thrift, and Avro are built on top of various encoding formats and offer RPC support. For instance, gRPC uses protocol buffers and supports streaming, allowing for a series of requests and responses over time. These frameworks can simplify asynchronous actions and service discovery, making them useful in certain contexts. However, RESTful APIs come with significant advantages. They're great for experimentation and debugging. Developers can make requests using a web browser or command line tools without needing extensive setup. REST is supported across all major programming languages, and there's a vast ecosystem of tools available for monitoring, testing, and debugging. Now, let's shift gears and talk about message brokers. These are intermediary systems that facilitate communication between processes, allowing messages to be sent without a direct connection. This setup has several benefits, including reliability, as message brokers can act as buffers if a recipient is unavailable, improving system reliability. They can also automatically redeliver messages if a process crashes, preventing data loss. Another advantage is decoupling. Senders don't need to know the recipient's address, which is especially useful in cloud environments where services may frequently change. Additionally, one message can be sent to multiple recipients, enhancing communication efficiency. Typically, message brokers operate in a one-way communication pattern where the sender doesn't expect a reply. This asynchronous communication allows for greater flexibility and scalability. In the past, the landscape was dominated by commercial software, but now open-source solutions like RabbitMQ, ActiveMQ, and Apache Kafka have gained popularity. These brokers allow for complex messaging patterns and can handle a variety of data formats, making them adaptable to different use cases. As we wrap up, it's important to note that while RPCs and SOAP have their place, RESTful APIs and message brokers are increasingly favored for their simplicity, flexibility, and robust ecosystems. Whether you're building a public API or managing internal communications, understanding these concepts will help you make informed decisions about your architecture. Thanks for tuning into this episode. We hope you found this exploration of Wsdl, SOAP, REST, and message brokers insightful. If you have any questions or topics you'd like us to cover in future episodes, don't hesitate to reach out. Until next time, keep coding and stay curious.